knowledge about things in terms of miles per hour and kind of go roughly into it. 15. You think 15?
Yeah.
You think a square 15? I don't know what the answer is.
Just do 10. Okay. Do 10. Make it easy for yourself, guys.
I'm gonna look it up.
At least it's not like.
We'll go with 10 for ease of calculation.
Oh my god.
So,
This is so
if I have
cool.
a string which is self-responding.
You're there. You're there now.
This is neat.
So if we have a soccer ball which weighs half a kilogram and it's kicked at 10 meters per second, how much kinetic energy should it have? What's 10 squared?
75 miles per hour. That's what Ask.com said.
Really?
The speed of a soccer ball does travel is estimated to be around 75 miles per hour. In reality, it depends on the strength of the player. The stronger
Faster than a speeding car?
I don't know. So Ask.com said. The other one. It said nearly 132.
Maybe like.
What?
It said 132.
Wow.
I don't think it
Wave high.
Really puts speeding goalie in a different perspective. You have things, soccer balls hurtle at the speed of a speeding car.
120. Oh wait, the average kick is 85 to 90. The average kick is 85 to 90. Mr. Ahola.
Gloves.
Mr. Ahola. The average kick is 85 to 90.
That's so
All right, well let's go for call this 100 meters per second. I guess I should actually be projecting this. All right, what's 100 squared?
1,000.
Oh,
100,000. No. 10,000.
look at that board.
10,000.
That is a board. That's what we're doing.
4 zeros, right? 100 times 100, 2 zeros, 2 zeros, 4 zeros, 10,000. So, we have a half. We said the mass is a half, and we said v squared is 10,000. What is a half of 10,000? What is a half of 5,000?
22,500.
So the soccer player did 2,500 joules worth of work,
It's a lot.
roughly. But here's the question.
No.
If I dropped the soccer ball, and that was how it reached the speed, from what height would I have to drop a soccer ball for it to acquire? Whoa!
Oh, that makes sense.
So if I want to say,
What happens if I take a selfie?
if I want to say how high does it have to be?
That's what
right?
happens. Can I
So
see it
the
in here?
question is, if I have it at this height, then it has gravitational potential energy. I want to know how high does it have to be to have this much kinetic energy once it's kind of done falling. So I'm going to set the initial gravitational energy equal to the final kinetic energy. So our initial mgh is equal to our final 1/2 mv squared. We find out an interesting thing here if we look at this. What doesn't matter in terms of the speed of the dropped object? So the idea is that it's harder to accelerate a big object, but gravity pulls more on a big object. So it doesn't matter if this is that whole, like, Galileo's thought experiment, but if I drop a feather in a bowling ball. In the absence of air resistance, if I drop the feather in a bowling ball, they would both hit the ground at the same time. We spent like a half a period playing with the coin and feather too, like a month and a half ago, 2 months ago. Well, that's why in the absence of air resistance.
Okay.
Yeah. With air resistance, yeah. But. So if we look at this, we're going to say that the height it has to be dropped from is 1/2 v squared divided by g. Right? We good with that? So if I'm saying if I want the ball to have this much energy because I dropped it, not because I kicked it, then how high do I have to drop it from? Well, I have to drop it from a height so that the energy it starts with is gravitational potential energy. So that's going to be equal to the kinetic energy it lines up with. I could do that also. So I could have just said that MGH is equal to 2,500. That might actually be easier. So H is equal to 2,500 divided by 0.5 times 10. So what's 0.5 times 10? 5. So now we have 2,500 divided by 5. What's 2,500 divided by 5?
500. Is that right?
Yeah.
Yes.
So we would have to drop this from half a kilometer up in order for it to achieve the same speed due to falling from gravity as kicking. Which means that this ball was kicked with a force significantly stronger than that of gravity, because the kick only went like, you kicked it through a couple of centimeters maybe, versus having it fall 500 meters. So if you didn't already have this calculated.
Oh, because it's on both sides. You can
Yeah.
find out. Okay, got it.
Yeah. All right. Reasonable? Okay, we've got about a little more than 10 minutes left. You guys can have this time to work on tonight's homework or your lab report. Your lab report, which is due on Friday. All right. I know that you guys have like other stuff due this week and next week. I believe the history paper is due on Friday or something.
No,
Wait, what?
Whoa.
Oh,
Oh.
Breathing.
Okay. Anyway, point is, the lab report should not take you very long after the time I give you in class. You should be able to get a lot of your work done here. Okay? So,
Everything that started breathing my.
history paper.
I like
Yeah, my answer was like 3 minutes, and I was like, how long should it be? And she was like, well, it doesn't really matter how long it is. And I was like, why you work
So
on
generally you got like 3 or 4 history classes to work on this week.
So cool.
Yeah.